All right, there we go. So, in honor of the season and the topic that we have coming up, I would like to just very quickly show you some of my favorite costumes for Roombas. So if for some really weird reason you own multiple Roombas, the whole Pac-Man and Ghost costume thing, totally awesome for your Roomba. This one here is same in the video game theme. That is so cool. I'm jealous. Koopa Shell from Super Mario Brothers. So Roombas scare the shit out of pets. This will haunt their dreams for life. Very cool. And then if you're a Roomba and you actually want to go out, I like this whole modern update on the witch costume. I think that's kind of clever. Very cool. So anyway, these are my favorites. Roomba costumes for Halloween, which you can do. And now, last but not least tonight, the promise of real personal robotics from Robot App Store and Robots Lab. Please welcome Ila Dimbar.
Okay, so let's turn on this little guy. So, I know that you're all tired and want to go home, so we'll do it really quickly. So my name is Ila Dimbar. I'm CEO and founder of Robot App Store, the first marketplace for apps for robots. And Robots Lab, which is a boutique firm that basically designed to help students in all kinds of ages. Just a second. Okay, which basically designed to help students in all ages to learn better, especially math and science subjects using robots. So this is what we are doing. I'm working in the intersection of robotics and education for almost 8 years, and robots were my passion from childhood. So for many years, robots were basically just, toys for geeks. You need to build them, solder them, put all the wires in them, and you can't really get a robot. And in the recent years, we're actually starting to see these kind of amazing machines that are really capable. They can do a lot of things, basically fully programmable, so we can do everything that we want with them. Just a quick question: how many of you saw this robot before? Okay. Yeah, that's fair. By the way, if you wonder about my accent, my name, I'm Israeli. So just, I know some of you have some questions. Anyway, we'll start the talk with a short presentation that the robot that is called NAO will give in just a second. It's still booting up. It's a computer after all. This robot is actually manufactured by a French company called Aldebaran Robotics. They're based in Paris. And this is an education and research tool. So you can't buy it for your entertainment, get Coke from the fridge or whatever you want to do with your personal robot. They sell it only to educational institutes and research institutes and so on, which is, a bit of shame, but that's life. That's where we are right now. Still loading. It should start blinking when it wakes up. Here we go. Good. So, without further ado, let's start.
Hello, Ellen. Are we in the meeting you talked about yesterday?
Yes, we are.
It is so dark. I can see only 15 people. That's all? I expected a bigger audience. After all, I am the most advanced robot on the planet today.
Which is, by the way, true. I mean, that's the latest and greatest robot that you can get, for not too much money.
Hello, nerds. My name is Now. Although it looks like I came back from the future, I live among you today. Listen carefully, you will be tested. I'm a humanoid robot, imagined and manufactured by Aldebaran Robotics. I come with a software and I'm fully programmable. I'm autonomous, and I can connect to the internet through Wi-Fi. I can recognize your face, answer your questions, play music, grab objects, and even play soccer like a pro. I've more than 4,000 brothers and sisters and use all around the world, in universities and research laboratory. Do you want more technical details?
Yes.
Counting every articulation in my body, I have 25 degrees of freedom. The sonars located in my torso allow me to detect obstacles that I might encounter. My 2 cameras give me an enlarged field of vision. Thanks to them, I can look right in front of me or at my feet, to avoid walking where I should not. The 4 microphones around my head allow me to detect the origin of sounds nearby. Oh, well, I think about it. There are 4 force-sensitive resistors under each of my... Combined with my inertial sensor, they help me keep my balance. I can use some LEDs to express various emotions and interact with you. And you, on the other hand, can use my tactile sensors on the head, for example, to pass me some information. Well, I guess that's enough for the moment. Thank you for listening to me. It is a great pleasure to come here to NerdNite SF. Me and my brothers are researching robotics, artificial intelligence, computer vision, and many other topics like physics and HI. We also research interactions with autistic kids and help for elderly people. I am a great platform, isn't it? So you see, during my day, the professors are abusing me with their requests and tasks. Like getting their Coke from the fridge. Really? Come on. You can get your own Coke by yourself. So when the professors finally go home, I have free time for entertainment. Like dancing. Join me. On and on. But boss says there is a presentation to watch. I'll rest quickly here.
Okay, so thank you, Lil. Now, so who said robots can be fun and cute and it just stay like that? You can go back. Sit down like a real person. Okay, so I really, like your feedbacks. It's really fun to see that every time, again and again, how people react to these robots. So. With that, let's just start talking about that. So, what are robots? What is a robot? When we try to think about it. So, if you're a 3 years old child, this is probably your perception of robots, which is fun and tasty and everything, but not really what we are trying to do here. So, robots are basically, if we think about it, they are basically computers with motors and sensors. Nothing more than that. It's basically a computer that can interact with the environment and can actually sense the environment. That's the only difference between a computer and a robot. Okay, just to set up expectations. There are not any, our next lords or something like that. Just a computer. For many years, and we are in 2013, almost in 2014, for many years, we were promised that we'll get our, personal robot that will help us and work with us and, do everything that we want. But it's not here yet. And actually, I guess you all know Rosie from the Jetsons. She was like the best personal robot ever. She could talk and clean and help the kids with homework and pick them up and do everything that you want. And do you know when this program was aired? Any idea? 1962. So we are a little bit more than 50 years since it was envisioned. But honestly, the only Rosie that we have is basically that. We are far away from having Rosie. And just to be honest with the TV show, which was great, the creator actually put that in 2060 to 100 years from the creation of the show. So we still have 50 years to get there. We might be. As Seth and my other colleagues here said earlier, we will be there. So where we are right now. So if we think about robots, this is probably the only robot that we can get that can help us. It's not even a robot, it's just a presentation animatronic in Epcot Center in Disney. Nothing special, it doesn't even vacuum the carpet. Doesn't do anything. We do have these little robots that actually can play Gangnam Style. You can't hear that, but anyway, you saw some of that earlier. It's basically Gangnam Style, which is a lot of fun, especially if you think about students that programming the robots to do that, and basically engaging them in science and technology and engineering and everything, which is a lot of fun for them. But if we look at what Hollywood promised us over all these decades, then we're talking about robots that can interact with us, can understand all kinds of human gestures, can understand context, and can really interact with us. The problem is, it's a CGI. It's not even close to be real. Some of the robots are actually, looked real and even scratched and everything, and they can do something that we really want. But that's unfortunately even this one is just a CGI. So the distance from having this future that a robot like Asimo will basically play with our kids is unfortunately also CGI. And the reason I know that this is CGI is that Honda's engineers will never let Asimo run in the dirt. Imagine, this is like $400,000 robot. It will never go out of the lab and play like that. So, where are we right now? There is a... Just a second. there is a very interesting soccer competition that's called RoboCup. And RoboCup is actually, they set the goal to basically have a team of robots winning the, a soccer game against the world champion. And the goal is to do it by 2050. And as I think Seth said earlier, the reason they set it up to be 2050 is because none of the professors that actually set up the rules will be there, will be in their position. And the idea here is not just to have robots playing soccer, which is a lot of fun. The idea is actually to make sure that robots can be autonomous, can make decisions only based on their sensors. You see, this team would never win even against the kindergarten league. But by the way, this is last year's competition, so we are pretty far away from that, as you can tell. So let's take it from there. So basically, I mean, if we think about it, and if you have the urge to go and open your own robotics company, and you go to investors, they all tell you, focus on one of these three, big Ds. That's where robots should be. And the reason is that this is where the money is. So dangerous means all the factories. This is actually in Tesla Motors a factory not far away from here in Fremont. We'll talk about it in a few minutes. Dull, which is basically do everything that no one wants to do. And the dirty, that basically things that we want someone else to do. And this picture is actually from the Fukushima reactor after it exploded. They sent one of the robots over there, one of the iRobot US company, over there to check what's the status. So if you want to open your own robotics company, everyone will tell you focus on that. That's where the money is. This is where the robotics companies can actually contribute. And it's really interesting because if you look at the academia and what's happening in the universities and so on, this is actually from yesterday. There is a humanoid a conference running these days in Atlanta, and that's basically the stage where the humanoid robots are basically strapped to these bars over there, and that's the way that they can walk. If you pump a company with a little bit more money, like these guys, you'll get something which is a little bit more encouraging. It can actually walk, it can avoid obstacles. I guess most of you saw this video. This is basically part of the DARPA challenge that designed to send a humanoid robot to some kind of scene like the Fukushima area and actually be able to handle all kinds of disasters over there. So we can get that, but the challenge with this is still teleoperated. So there is a person behind it that runs that, and actually the first years of the humanoid challenge are basically all of the robots should be tethered. So nothing autonomous, nothing smart, intelligent, and so on. So there are three challenges if we are trying to basically look at the robotics world, where it is today, and how far are we from having one of his big brothers in our homes helping us. So the first challenge is basically very simple. It's not a 747. That's not the challenge. The challenge is this. Computers are very good in one thing, which is compute. Right? That's what we build them for. This is an amazing computer. Okay, it's not just an airplane. Okay, today we can basically take this amazing machine, fill it with like 500 people, tens of tons of fuel, and actually send it over the globe from San Francisco to Singapore without a person in the cockpit. Okay, and it can do it perfectly. And the reason is that this is a very well-defined task. Okay, we know what we need to do. We know where we should get. We know, what's the velocity. We know what's the takeoff direction. We know everything about everything. And if we don't, we can sense that in the way and improve our flight path and everything. The challenge is, as I said, Rodney Brooks, one of the leading researchers in robotics, is that there is no robot today that can actually put its hand into the pocket and just pull one thing. Okay, this is something that is called unstructured environment. We don't know how the key looks like. We don't know where it is in the pocket. We don't know if we have more things in the pocket other than just the key. And there is no single robot, that can do that. And the reason is that first, we don't know anything, and the second, we don't have the dexterity. We don't have the sensing ability to actually detect these kind of things. Our body is just one huge sensor, if we think about it. So this is something that is not possible. We can't, with any robot, we can't just pull out just one key from the pocket. And obviously we cannot pull a cat from a pocket. It doesn't work as well. Another thing we cannot do today is actually we cannot just open this bunch of money and just pull one of them. If it was US dollars, I guess we could. But since this is euros or I don't know, pounds, we can't. Another thing, we cannot basically pick up just one of these screws. I cannot tell a robot, go and bring me this half-inch screw with this and that. And the reason is that, again, we cannot work. We don't have the dexterity, and we cannot work in an unstructured environment. Robots simply cannot do that. So that's the first challenge. The second challenge is basically safety. So it's self-explanatory, right? That's why they created these labels. And this is actually, if you look at that, this is a video from the Tesla Motors company. And everything is automatic over there. There are, robots that basically lift these cars and, move them around and everything. And humans are not allowed to be around the robots. They are in their own special zones, safe zones. And if someone will basically walk near this robot or put his hand over there, will be hurt because this robot can't detect anything around it, and it's not safe to be around it, which is, a bit of a problem if we want robots to work with us. We want robots like that. We want the robot to work with us. We want the robot to be safe, and even if the robot is holding a knife, we want to feel safe around it. By the way, this is not CGI. That's a real Japanese company, Motomen. So the second challenge is basically make the robots safe for humans and the surroundings. The reason I mentioned the surrounding is think about the autonomous car from Google. That's basically a robot. It can hurt not only people, it can hurt other objects and everything. So they must be safe. The third challenge is basically context. We need to understand context. It's not easy. Even for us, human. It will take a lot of time and a lot of efforts to try to basically bridge this kind of abstract notion of reality. It depends where I'm coming from. It depends, what I've been through. It depends in so many different things in order to understand the context that, where I am right now and what I should do next. Do you want to sit in an autonomous car in this left turn? I don't think so. And that's one of these problems. If the cars are trained to detect traffic lights and they cannot read, that's a problem. And we don't want to be in this kind of problem. If we think about it, the robot mentioned bring Coke from the fridge. This simple request is so complex today. Just thinking about it, and robots actually cannot do that. Even computers cannot do that. Just think about it. What is a fridge? Okay, it can be like that. It can be side by side. Okay, it can be with drawers. It can be even something like that. If one of you rented, an apartment in San Francisco, I guess you faced one of these. So, I mean, fridge, is not a well-defined object that we know how to handle that. Just imagine how the robot should open the door over there and just like pick up one of the cans from the door. Not only that, Coke comes in different shapes. Okay, I won't mention them too many times. Maybe Pepsi, I don't know. I mean, it can be a can of Coke, and God forbid if the robot will have to open that. Okay, you will be thirsty for the rest of your life. Okay, it can, be like that. It can be a small bottle, okay, that you can just, hand over, or a big bottle that we actually expect the robot to open that and pour it into a glass and serve in the glass. So bring me Coke from the fridge is not a simple task. I mean, we have to understand the context. And on top of that, every 4 years old child will know that this is a Coke fridge. Okay? And he knows to put the money over there and just to get the Coke. Honestly, I don't think there is a single computer vision software that can look at that and tell you, oh, that's a Coke machine. That's a Coke fridge. I need to get one of them, from belly of this robot. Okay, computer vision cannot do these kind of things today. To show you how far it is today, so we have guys from Willow here. I heard applauses. Okay, no. So this is probably the most advanced and also expensive robots available today. This video is actually sped up 50 times faster than what it actually happened here. And you can see, I mean, robots are super good with structured environment. So once the robot detected the towel, it's fine. But this kind of this probably takes like 5 to 7 minutes. On top of that, if you think about our universe, I mean, the world is much more complex than what we even think about it. I mean, just go over there and open the door and go beyond this door, outside or whatever, can be so many different things. And no one ever taught us how to open each one of these doorknobs. I mean, we intuitively understand that because we are learning. I don't want to think about a robot that will have to stand behind this restroom door without a doorknob and try to figure out how to open that. I mean, these kind of things, I mean, understanding the context is super important, and be able to generalize the problem. And, based on my previous experiences, what I should do now, this is something that is really, really hard. 5 minutes, good. But fear not. Okay, there are a lot of advancements in this field. So, to touch on the first point, the dexterity, this is actually a real product. It's not a CGI. Okay, there is a project that's trying to basically detect different kind of objects and different kinds of basically properties of the material and be able to handle that. I guess you all heard about the Da Vinci robot, the surgical robot. You can see over here how the robot actually peels a grape. Okay, so don't be afraid, it's not a human tissue over there. It's just a grape. But it's pretty amazing. I mean, look at the dexterity, look at it's pretty awesome. Okay, the challenge is that this is actually human operated. Okay, so there is no computer behind it. However, the company that created that, Da Vinci, Intuitive Surgical, actually recorded, since the surgeons are actually working behind this robot and actually moving that, they actually recorded all the motions of all the best surgeons in the world, and they actually created a way that the robot can actually just stitch the wounds by himself, and the robots are actually doing it much faster and much better than the best surgeon in the world today. It's not production yet, but I mean it's there. This is what happened when you put a real world problem into a computer. You turn a real world problem into computational problem and actually introduce it as just like a big data kind of problem. And these robots are actually doing it pretty efficiently and releasing the surgeons to go and do the next surgery, not spend 3 hours teaching the body over there. So dexterity and in unstructured environment is getting there. We're not far away. The second point is basically being safe for humans and for the surrounding. So I guess many of you saw this picture. This is basically how the Google car sees the world. The car actually can categorize different objects, people, people on bicycle, cars, and so on. I guess many of you already saw this robot, which is Baxter, a US company from Boston. And they actually built a robot that is safe to work with human, shoulder with shoulder, with factory workers. And you can see, people can actually interrupt the robot's in the middle of this operation. The robot will stop. The robot will look at that. Okay, make sure that things are clear and the human actually understand what's going on, and people can actually program that without any prior experience in robotics and computer science and so on, which is awesome. So we're definitely getting there. So robots are safe and becoming safer and safer. I didn't mention that, but the Google cars actually drove more than 1 million miles without any accident, which is pretty awesome. I mean, I didn't do that, honestly. The third challenge is actually understanding the context and be able to generalize based on what I experienced. And the problem is that context is super complex. If we're trying to imagine, all the connections in the world between all the objects and all the, properties and everything that we can do with that, it becomes so intense. We can't compute that. Even if we put all, Google's, server farms to solve these kind of, pretty simple problems, it's basically impossible. The good news is that there is another type of computer that it's basically a quantum computer created by a French company called D-Wave. And they are able to do something which is phenomenal. They can compute things, in a magnitude of, speed and efficiency comparing to the regular computers that we know. Funny story, Google actually sponsored one of these computers to the NASA Ames Center, which is right now under the government shutdown. So the computer is there just not doing anything. However, it's doing something because Google has their remote control over that. And they're actually optimizing, I just read an article, they're actually optimizing the algorithms behind the Google Glass, trying to make it more efficient and trying to make sure that, in this very small, light a computer environment, we actually need a lot of computation in order to detect, all the objects and everything, and still be connected and don't consume too much battery and so on. They were able to create an amazing compression algorithm for video that actually compress video to 50 times smaller than what the best compression can do today, which is amazing. Think about it, 50 megabytes of video can be in 1 megabyte. Okay, imagine, what we can do with that. They created an algorithm to detect how basically, the human body interact with all kinds of medicines and so on. So it's really encouraging. There are computers that can solve these kind of things. And this one, by the way, is faster and stronger than all Google's data centers around the world. Just one single computer. I'm not going, too deep into that, but this is an amazing advancement in computation. Just the ability not to compute things, one by one. So, in terms of context and generalization of the world, we are 5% there. The reason that I'm saying 5% is that this amazing computer actually runs close to the absolute zero. So it's like a container. Okay, with like huge power supply. It takes 6 weeks to boot it up. Okay, yes, but don't forget, 30 years ago, computers were like that. Okay, we used to feed them with, paper with holes in them. Okay, and today we have that. So 30 years into the future, we will be there. I hope faster, honestly. So, 2062, will we still see this rosy? I hope not. I hope we will see something much closer to that. And don't forget, this is just a CGI, which is basically robots that are able to work with us and able to, to understand the context and understand the meaning of, this environment, understand the, the different things and different, aspects of our lives. And basically, we want the robots to be adapted to our environment, and we don't want to adapt our environment to, what robots can understand and mean. So with that, yes, it's 2013. My personal robot is on the way. It will take a few years, but it will get there eventually. Thank you. We have time for 3 questions. So, yeah.
To get an idea, how much time did it take you to program what Neo did?
How much time it took me to program now? So I would say roughly 20-30 minutes. And the reason is that it's all predefined, blocks of code that I just put the text over there, and I can record the motion just by moving the robot. It has encoders on each one of the joints. Okay, so if you put the back office around all of that, it takes you, no time basically to program that. Another question. Yes, I can hardly see over there.
Okay. So I want to help out the first speaker from tonight. So if you put yourself 100 years in the future from now, and you were on another planet, how would you know that the robots exist on this planet?
So if I'm 100 years from now and I'm landing on another planet and the form of life over there is basically robots, how do we know that this is basically life, right? So I guess we wouldn't know. I mean, we can detect this kind of like silicon-based form of life with the regular absence or existence of oxygen or methane or whatever. I mean, it's totally different. I don't think, we need to ask Seth and the other guys. I mean, I don't think we even look for this kind of, habitable, planets. So I don't know. I mean, it's a question for them.
You two should have a beer together.
I'm sure, yeah. There was someone here waving. I can't see anything. No. Any other questions?
Elon, I have one for you.
Oh, yeah, sure.
If I knew nothing about personal robotics and wanted to do something and learn something, what would I do to learn? Where would I go?
So the question is, if I don't have any experience, I don't know anything about robots, where would I go? So the best answer will be go to university. And actually, we have a lot of schools. We represent this company here in the US, and we have a lot of schools that actually, kids are programming that. So if you want to go back to the 5th grade, feel free. But seriously, to be honest with you, there are no, too many, resources that are available for everyone. I will.
Next week.
There is a conference next week. It's Robo Business. It's in Santa Clara, not far away. It's mostly for the business side of robotics, but it's not for the educational side of that. But if you really want to start with something, I would honestly recommend something like the Lego Mindstorms or Vex kind of kits that are very hands-on without any. You don't need any prior experience in robotics or engineering. Just like every Lego, all these Scandinavian companies, everything just like IKEA thing. Put 2 blocks one next to each other and you get a robot. And the same for the software. So yeah, it's very simple, but you actually get the sense of what is a sensor, what is a motor, how it works together. How can I get data from one and apply it to the motor and do something based on that? These kind of things are really, really helpful. And honestly, there is a new Lego just released a new platform. But that's the best tool. It's like something like $350, and you have your own robotics kit at home. Yeah. With that, thank you very much. Have a good night.